Hello students, today I am going to explain about work energy principle. Before going into the details of work energy, the students must understand some basics very strongly. Okay, so I am going to explain about some basics which are essential to understand clearly the work energy theorem. So if you say an object is moving with a velocity of 10 meters per second. See, the object is moving 10 meters per second at t1, and the object will have same velocity of 10 meters per second at t2 also, at other instant also. That is the idea. Next, if you say an object is moving with an acceleration of 10 meters per second square, 10 meters per second square, the situation is as shown below. At 0 second, the velocity of the object is 0 meters per second. But when time increases to 1 second, the velocity increases to 10 meters per second. Similarly, when time increases to 1 to 2 seconds, the velocity increases from 10 to 20 meters per second. Similarly, when time increases from 2 seconds to 3 seconds, the velocity increases from 20 meters per second to 30 meters per second. Every time the increment in velocity is 10 meters per second. See that 30 is equal to 20 plus 10. Similarly, 40 is equal to 30 plus 10. Similarly, 50 is equal to 40 plus 10. Similarly, 20 is equal to 10 plus 10. And similarly, 10 is equal to 0 plus 10. So for every second, the increase in velocity to be 10 meters per second if the object is moving with the acceleration of 10 meters per second square. This is what is called the case of constant acceleration. Constant acceleration. Next, so the same thing is explained here. Now you see here the two cases. One is constant acceleration and another is variable acceleration. In the constant acceleration case, whenever time increases by 1 second, the velocity increases by 10 meters per second. See that at t is equal to 0 seconds, the velocity is 0 meters per second. At t is equal to 1 second, the velocity is 10 meters per second. When time is 2 seconds, the velocity is 20 meters per second. In this way, for every 1 second interval, the velocity increases by 10 meters per second. That is why here the velocity is increasing from 0 to 10 meters per second, then 20 meters per second, then 30 meters per second, then 30, 44 meters per second. But in case of variable acceleration, the situation is different. Here, for increase in time by 1 second interval, the increment in velocity, the increments in velocities are different. For equal increments in time, the velocities are increased by different amounts. For example, from when time increases from 0 to 1 second, and in the 1 second interval, the velocity is increasing by 10 meters per second. But in other 1 second interval, suppose if the time increases from 2 seconds to 3 seconds, the velocity is increased by 60 meters per second. See, in this 1 second interval, the velocity increment is 60 meters per second. But in this time interval, the velocity increment is 10 meters per second. But in the other 1 second interval, 4 second to 5 second, in this 1 second interval, the velocity increment is 20 meters per second. In other words, in the variable acceleration, you will find the velocity increases by different amounts in 1 second intervals. For various 1 second intervals, the velocity increases by different amounts. That is the case of variable acceleration. For constant acceleration, the velocity increases by constant amount every second. For variable acceleration, the velocity of the object increases by different amounts of velocity for each second. Okay, that is the difference between constant acceleration and variable acceleration. But the formula F is equal to ma, is valid whether acceleration is constant or acceleration is variable. See that when the acceleration is variable or constant, formula F is equal to ma is constant. If acceleration is constant, the force is constant. If the acceleration is variable, the force is variable force. Okay, this is here one important point is given. F is equal to ma is valid whether acceleration is constant or variable. But the formulas v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, All these formulas are valid only when the acceleration is constant. For general people, if you ask what if the total force is zero, if a force is zero on an object, the general people will say that the object will remain at rest. General people, not only general people, even we also say that the object will be at rest if the force is zero. And but science says that, but science the interpretation will be each different. Science says when there is a zero force, the object will be at rest or will be in uniform motion. That is the conclusion of science. In this way, the conclusion of science varies from the idea of general people. Okay, general people think that the object will be at rest when the force is zero, but science says the object will be in uniform motion when the force is zero. What is uniform motion? Uniform motion means moving in straight line with a constant velocity. Moving in straight line with a constant velocity. For example, an object in the space away from the sun and other stars will move with constant velocity along a straight line. Okay? Usually space objects move in straight line with constant velocity. Such cases corresponds to examples of uniform motion. Now let us see how the science come to the conclusion that when the force is zero, the object will be at rest or will be in uniform motion. For this, you consider this F is equal to ma formula, and if the total force is zero, if the F is equal to ma can also be written as F is equal to m into v2 minus v1 divided by t2 minus t1, because acceleration is equal to rate of change of velocity, or v2 minus v1 by t2 minus t1. Suppose if F is equal to 0, total force on the object is 0, then left hand side becomes 0, right hand side is m into v2 minus v1 by t2 minus t1. This right hand side also must be 0 because the equation should be satisfied. For the right hand side to become 0, mass can be 0, but mass cannot be 0. T2 minus T1 should be infinity, or T2 can be equal to T1. No, that is not possible. Time can never be constant. It is going to increase continuously. And so it is not possible. And V2 minus 1, only the numerator should become 0. Then only the right hand side also becomes 0, with the left hand side becomes 0. See, for the right hand side to become 0, only the numerator has to become 0. Here the numerator is V2 minus V1. V2 minus V1 can become 0 when V2 is equal to V1. And when the object is moving with constant velocity, thereby the final velocity is equal to initial velocity. Or if both V1 V2 is equal to 0, then also right hand side becomes 0. So the right hand side becomes 0 when V2 is equal to V1, that is when the object is moving with constant velocity, or when the velocities are 0, V2 is equal to 0, V1 is equal to 0. V2 is equal to 0, V1 is equal to 0 is possible only when the object is at rest. So science will say that when the total force is 0, the object will be at rest or will be moving with uniform motion, or the object is moving with a constant velocity. So Newton's second law, F is equal to ma, is implying that if force F is equal to 0, the body should move with a constant velocity along straight line, or the body should remain at rest. Next, come to this one. Suppose if two forces are acting on the object, two opposite forces, see, one is F1 and another one is F2, both are acting in opposite direction. Suppose if two forces are equal in magnitude, suppose F1 magnitude is 10 newtons, F2 magnitude is 10 newtons, but F2 is equal to minus 10 newtons, F1 is equal to plus 10 newtons. Why? Because F1 is along the plus x axis, F2 is along the minus x axis, therefore F2 is equal to minus 10, F1 is equal to 10 newtons. So total force on the object is F1 plus F2. 10 plus minus 10 is equal to plus into minus minus, so 10 minus 10 is equal to 0. So total force on the object is 0. See, according to Newton's second law, when the total force is 0 on the object should be at rest or should move with constant velocity. Here I say that the object will be at rest for the total force to be 0. the object will be at rest provided the ground has a lot of frictional force. If the ground has a lot of frictional force, when the total force on the object is 0, the object will remain at rest. But if the total force on the object is 0 and if the frictional force of the ground is very negligible, if the frictional force is almost 0, and if the even when the total force on the object is 0, then the object moves with uniform motion or moves with a constant velocity. What I say that according to Newton, when total force is 0, the object should be at rest. Yes, the object will be at rest provided the frictional force is very large. Again, when the total force is 0, the object should be in uniform motion. Yes, the object will be in uniform motion provided the frictional force is almost 0. Frictional force is almost 0. Usually ground offers considerable friction. Therefore, if an object is there on the ground and if the total force on the object is 0, the object will be at rest. But if you consider objects in space or some other thing, when total force is 0, since there is no frictional force, the object will move with a uniform motion. We can see such a practical example in the coming slides. See, if an object is falling, if the object is dropped, it falls towards the earth with an acceleration of 10 meters per second square. This acceleration is constant, and this is very important for us. Usually on the earth, if you drop a ball at certain height and at the beginning instant, say 0 seconds, the velocity is 0 meter per second, but when time increases to 1 second, the velocity is increasing to 10 meter per second. Similarly, when time increases from 1 second to 2 seconds, the velocity increases from 10 to 20, increased by 10. Similarly, when time increases from 2 seconds to 3 seconds, the velocity increases from 20 meters to seconds to 30 meters seconds. That is, velocity is increased by 10. So acceleration is equal to v1 minus v0 divided to 2 minus t1 is equal to 10 meter per second square here. Here also the acceleration is 10 meter per second square. Here also the acceleration is 10 meter per second square. This special acceleration of the object above the earth is also denoted by letter G. G is called acceleration due to gravity. Okay. We can also calculate gravitation force. Gravitation force formula is m into G. Since everywhere acceleration is constant, G is constant to be equal to 10 meter per second square. Even when the ball is at this height, gravitation force is equal to 10 newtons. Even when the ball is somewhere here, then also gravitation force is 10 newtons. Even when the ball is very close to earth, there also gravitation force is 10 newtons. Okay, now I am going to define field. Any field, gravitation field or electric field or magnetic field, like that we have 3 fields. Any field can be defined as force divided by the property of the object on which force is acting. This is the definition of any field. Suppose let us define gravitation field. Gravitation field is equal to, in the numerator you have to take force. Here we should take gravitation force divided by the property of the object on which force is acting. Gravitation force acts on mass only. Therefore, in the numerator gravitation force we should write Fg. In the denominator we should write M. Gravitation force field is also denoted by letter G. Because Fg is equal to M into G, and in the denominator there is already M is there. This M and this M will cancel and the result is G. Therefore, gravitation field is also denoted by letter G. G is called acceleration due to gravity or gravitational field. The gravitational field is shown by vertical arrows. Above the earth at every point, G is equal to 10 meter per second square. This case is valid above the earth up to 200 kilometers, something like that. Okay. And if you drop a mass of 1 kg, the gravitation force on the mass is Fg equal to m into t, 10 newtons. But acceleration is still 10 meter per second square. If you drop a mass of 10 kg, the gravitation force on the mass is Fg is equal to mg, 10 into 10, 100 newtons, but acceleration is still 10 meter per second square. If you drop a mass of 20 kg, the gravitation force on the mass is Fg is equal to m into g, 20 into 10, 200 newtons, but acceleration is still 10 meter per second square. What I want to say that here in the first case I have taken mass is equal to 1 kg. Force is 10 newtons, but acceleration is 10 meter per second square. In the second case, I have taken mass to be 10 kgs, force is 100 newtons, but acceleration is 10 meter per second square. In the third case, I have taken mass is equal to 20 kgs, force is 200 newtons, but acceleration is 10 meter per second square. From this, you can say that independent of the mass, the acceleration is constant. This is one of the greatest conclusion of science. This is one of the greatest conclusion of the science. The science says that if the even when the mass increases, even when the mass increases 1 kg to 10 kg, 10 kg to 20 kg, the acceleration is constant, 10 meter per second square, 10 meter per second square, 10 meter per second square. This is surprising thing for ancient people, because ancient people thought that heavy masses move with high speeds, lower masses will move with slow speed. Okay, that is the idea of ancients. That idea continued for about 1700 years, 1700 or 2000 years, for about 2000 years. Only it was corrected in 1590 or 1600 AD by Galileo, who said that independent of mass, all the masses will fall with the same acceleration of 10 meter per second square. This is surprising conclusion and revolutionary idea. Okay, but for the present day people, it appears to be simple, but it took nearly 2000 years for human civilizations to understand this concept. Now you take this what is called ball. On the ball there is a downward force, and downward force is there because the ball is in air. The downward force is gravitational force. Upward external force is we are applying. External force is applied in the upward direction, and here external force is applied in such a way that Fx external force is exactly equal in magnitude to gravitational force. What I am saying, that magnitude of external force is equal to magnitude of downward gravitational force. See, since both forces are equal and opposite, the total force on the ball is zero. When the total force on the ball is zero, earlier I said that when the force is zero, the ball can be at rest or will move with a constant velocity. I also told you that the body can move with a constant velocity when total force is zero. That body can move with constant velocity only when the frictional force of the medium is zero. Here you are taking air. Air is above the earth, so air frictional force is very negligible. Therefore, when the total force on the ball is zero, the ball moves with constant velocity from point A to point B. So even in the gravitation field, it is possible for the object to move with constant velocity opposite to gravitational field, provided if you apply external force exactly equal in magnitude to gravitational force but in opposite direction. So this point is very essential to understand work energy principle. I continue in the next video. Thank you.